Hello everyone, this is going to be a nice and short video on 3 quantum number example problems just to make sure that you can differentiate between the easy, simple problems and then the more specific, complicated problems that deal with the actual definitions of the quantum numbers. So let's start with question 1, which is which of the following quantum number sets is or are possible? And in order to answer this question, what we're going to do is we're going to start with just our rules. So our rules are that n can be any positive integer. So 1, 2, 3, all the way to infinity. L is going to be restricted by the value of n. So L can be 0, 1, 2, but its maximum value is going to be n minus 1. M sub L is going to be restricted by L, where M sub L can be any value between negative L to positive L. And then n sub s, don't get too tripped up on it. It can just be positive 1/2 or negative 1/2. Either choice would be possible. So for question 1, we're just looking to follow these rules because we're not provided with any specific information. We're just looking at which of the following answer choices will follow the rules that I just wrote to the right. And so for A, we see that all those rules are followed. N is going to be your highest number. L is going to be less than n. M sub L is going to be within a range of -3 to +3. And then M sub S is 1/2. So that is going to be correct. Now B, you want to be able to tell yourself exactly why B is wrong. N is 3, L is 4. L being greater than n means that that is not a valid quantum number set, so that is incorrect. C, once again, follows the rules. L is a value between 0 and 3, which would be the acceptable values there for that n equals 4 value. And M sub L is equal to L, which is totally acceptable. It is within a range of negative L to positive L. It's just 0. So that is correct. And D, once again, follows all the rules. And you want to go through each of those quantum numbers and kind of tell yourself why. N is equal to 3, L is equal to 1, L is between 0 and 2, which would be the acceptable quantum numbers there. And then M sub L is within a range of negative L to positive L. So that is definitely correct. But then we go on to a more specific question. So this one is saying, which of the following quantum number sets is or are possible for an electron where n is equal to 4? And so now we need to zero in on these same answer choices, and what we're going to do, spoiler alert, is remove one of those answer choices. So we see that for A, this one is definitely correct because n is equal to 4 and all those other rules are followed. B is still wrong. C, once again, n is equal to 4, and all those other rules are followed, so that is true. But D is not correct now, because n is equal to 3, and so that's not going to describe this particular electron. So for question 3, I want to introduce one more quantum number that we can provide in a question stem. And so now we're saying which of the following quantum number sets is or are possible for a 4s electron. And the way I want you to interpret this is that that 4 is going to be the n value. And then that s is going to be our L value. But what value do I associate with this particular shape? Well, let's just recap that rule. So if L is equal to 0, that is going to be an s orbital. If L is equal to 1, that is a p orbital. If L is equal to 2, that is going to be a d orbital. And it's going to repeat like that. I'll give you one more. If L is equal to 3, that's going to be an f orbital. All right, so if this is a 4s electron, we're providing you both the n and L value. And you should now see that the L value is equal to 0. So even though in question 1 we said that this was an acceptable answer choice, this was acceptable, and this is acceptable. Now we know for this specific example of a 4s electron that we do need to look at this column carefully of these L values and see that A has L is equal to 1. That's going to be a 4p orbital, so that's not right. B was never right. And then C is a N is equal to 4, L is equal to 0, so that absolutely works. And then for D, we actually have a 3p orbital, so that is not going to be correct. And so hopefully what this video will show you is that there are different levels of difficulty here, but the better your fundamental understanding of what these quantum numbers actually mean, in addition to the rules, will really help you solve even the most difficult problems that we can ask you.